you track your health even before a doctor's visit? It's all thanks to a simple, non-invasive optical system that measures tiny changes in blood volume under your skin. This simple, light-based tech is called photoplethysmography, PPG in short form for those who would have troubles pronouncing the long word. And it's the foundation for heart rate monitoring you see in almost every modern-day wearable. This cool tech actually goes way back to the 1930s, when people first used it just to check out how blood flows. But get this, it didn't really hit the clinics until the 1980s. That's when it totally changed how doctors measure blood oxygen levels when you're in for a checkup. The way the PPG sensor works is beautifully simple. It has two main parts, a light sender and a light watcher. The light comes from a controlled LED, which is just a tiny focused flashlight, often sending out green light. Then the photodetector is the watcher, the dedicated eye that waits for the light to bounce back. The photodetector is basically the tiny eye of the instrument that turns the brightness it catches into a simple rush of electricity called a current that gets stronger the brighter the light is. This lets the device know exactly how much light is reflecting from the tissue. While we observe the core mechanism, the color trick, the dance between light and blood, we ask the question, why green lights? It is because it gets through your skin nicely and gives a strong, easy signal. Especially at the wrist, green light also works great because it gets strongly absorbed by the protein in your red blood cells. We call it hemoglobin. This makes it super effective at spotting volume changes, like that rhythmic pulse flow that happens every time your heart beats. Most modern-day smartwatches uses green lights and photodetectors. Doctors sometimes use infrared light because it can look deeper into your tissues. Observing the pulse cycle. During the pulse, the squeeze, when the heart pushes blood out, the blood vessels in the tissue swell up with a high volume of blood. This thick blood acts like a curtain, causing the hemoglobin to soak up most of the green light. The result is a sharp drop. Less light returns to the sensor, registering a low electrical signal. Between pulses, the retreat, when the blood briefly drains from the area, the vessels become less full. The curtain thins out. Immediately, more light reflects back to the sensor, registering a high electrical signal. The detector measures this constant rhythmic shift between the high and low electrical signal, creating a perfect map of the timing of your pulse. But the method goes deeper. It uses this pulse map to calculate heart rate variability, HRV, a smart way to measure the subtle timing differences between each beat. The sensor calculates the precise time interval between the highest point of every pulse, pulse-to-pulse intervals, or PPIs. By doing quick math on those tiny changes, the technology figures out what your body's autopilot, or ANS, is doing, giving you unique data on your stress and recovery levels. Now everyone's using it. You've probably got this technology in your smartwatch, checking your health right now. The best spots on the body to get a super clear PPG reading are the wrist, fingers, and earlobe. The only requirement is that the device must be snug and correctly positioned. Just a quick heads up, the raw PPG signal is often messy and needs digital filtering before it's reliable. Anything that throws off the reading is an artifact. The main culprits are things like moving around a lot, flexing muscles, or even just bright sunlight getting to the sensor. Plus, if you have a dark tattoo right where the sensor sits, or if your device is too loose, the light gets blocked. That's why the gadget needs super smart processing. While simple heart rate is usually fine, detailed analysis can be less accurate because of all these distractions. Another interesting factor is that naturally stiffer arteries as we age actually change the pulse signal, which the device also has to figure out. Thus, when it is performing an incredible hidden light and shadow show that tells the entire detailed story of the pulse beneath. It is quite simply an amazing piece of simple science. If you like more content like this, please like and subscribe to our channel.